fast forward through this part. I'm going to go over these two examples on the side. So you can save yourself a minute or two by forwarding that. So the pattern is you take the cube root, and so that's going to be x, and you take the same sign, plus, and you take the cube root of that also, so that's going to be 5. So that's going to be x plus 5. Then you're going to square this. So if you square that, you're going to get x squared. Then you're going to take the opposite sign. So that was plus, so this is going to be minus. Then you take the product of those two things, the product. So the product of 5 and x is 5x, and you already got the sign. You already have the sign, so that's not coming into play there. And then the last thing you do is you square that. So that's going to be plus 25. So hopefully you remember that. It comes back. You've done that the last 2 years probably. So if you know what you're doing, you want to fast forward and go back over there. If you want to practice one more time, so you can pause the video and practice this. And when you practice, the point is to do it without looking. So you want to cover that up there. You want to cover up the work up there. It doesn't really do any good if you're just copying the exact steps. You're not really thinking about it. So you want to try this yourself. So cover that up and try to remember. We said pause, try it, play. Here it goes. So the cube root of that is going to be 4, and the cube root of that's going to be x squared. And then we're going to take the same sign, so that's negative, and the cube root of 1 is. So that's going to be 4x squared minus 1, which is the difference of two squares if we need that, but we don't right now. We're just practicing. So then we square this. So that's going to be 16x to the 4th. I guess I could have color coded that for you again. So then we take the opposite signs. So that's going to be positive, and then we multiply those together. It's going to be 4x squared. Again, not use it. We already did the sign, so not really using that. And then we square the last thing, so that's going to be plus 1. Okay. So, little review on the side there. Now, if we come back to our problem was 8x cubed minus 27. So, if we take the cube root of that, that's going to be 2x. Same sign, minus cube root of 27 is 3. Again, pause, do it yourself as much as possible. Like, this is your main learning experience. Pause that video, use this practice. That's what we need to do. Square this, 4x squared. Opposite sign, so positive, multiply those together, 6x, square that, plus 9. Now this should happen almost pretty much all the time. That's going to cancel. If something doesn't cancel, then we might have done something wrong. Okay, now we can use direct substitution. So now if we come over here and we plug in 3 halves, 3 halves squared plus 6 times 3 halves plus 9. So that squared is 9 over 4. So the 4's cancel. We just have 9. Here, 6 over 2 is 3. 3 times 3 is 9. 9. So that's 27. Okay, so even though, we already talked about, even though this function does not exist at 3 halves, because we'd be dividing by 0, it still has a limit at 3 halves. It may or may not have a limit. In this case, it does have a limit. Okay, so I already pre-highlighted some of this stuff. I think it's helpful to know the names of the things. It reminds me of what I'm supposed to do. So I see this and I go, oh, this is good chance this is going to be the dividing out technique. Okay, you could try direct substitution, but then you're going to see you're dividing by 0, so that's no good. So factor and cancel. So that's going to be x, x. Usually the factoring is not that bad on the AP test. So 1 and 5, it's got to be, and then negative in the middle, so this is going to be negative, and this is going to be positive, which we also should have a hint that it was going to be x minus 5 because it's going to cancel. So those cancel. Now we can use direct substitution. So we just plug in 5. 5 plus 1 is 6. All right. Now, rational expression. Let's see what's going on here. That's going to be 3x plus 3 delta x minus 3x over delta x. Delta x is a variable by itself. It just has two characters. So you notice that the 3x and the minus 3x cancel. Now we're going to use the dividing out technique right here. And that just is 3. Okay, now, so you want to look for those different types of problems. I'm going to have a direct substitution. I'm going to have a dividing out technique. I'm going to have a rationalize in the numerator technique. So you want to look at those. Okay. Be familiar with each type. We don't really use rationalize in the denominator in calculus, so you don't really need to rationalize denominators, but we do sometimes need to rationalize numerators, because here if we plug in 3, this would be dividing by 0 again, and that's undefined. So the way you rationalize the numerator, it's the same process when you rationalize the denominator, so it wasn't a waste that you learned how to do that. It does help us here. So if we were in class, I would say, what do we need to do here? And hopefully some of you would answer multiply by the conjugate. So the conjugate is going to be that. That's negative, that's positive. And we're going to multiply them both by that. So in the numerator here, that basically cancels out. And so we're going to have x plus 1, and then we're going to have negative 2 radical x plus 1 and positive 2, and that cancels out. So negative 2 times 2 is negative 4. So we have that. Now, do not multiply out the denominator. Leave it alone. Leave it alone. Put it down. Stop. Okay. So this is x plus 1 plus 2. And do not multiply that out, because what's going to happen is the numerator here is going to reduce to x minus 3. And this is going to happen every time, and these are going to cancel. Okay? That was the whole point of that. So now we have the limit as x approaches 3. Now remember, when that cancels, that's a 1. So the numerator is 1, and x plus 1, square root of x plus 1 plus 2. Now we're going to use direct substitution. So that's going to be 1 over the square root of 4 plus 2, which is 2 plus, so that's 1/4. Okay. So pause the video and try the next one. So you see a rational expression, you see a radical in the numerator. It's probably rationalized the numerator. Okay, so again, the pausing and doing the examples yourself is probably one of the best things that you could do here to make sure you know what's going on. So do not get, well, the 7s and the z's are a little, but sometimes when people do the conjugates, they get confused by the sign inside. That, like, it's not, we're not changing the sign of that. It's just in between the two terms. Okay, so that times that radical times that radical, it basically just cancels the radical. The middles are going to cancel, and then minus 7 there. So here we have z times the square root of 7 minus z plus root 7. So these 7's cancel out, and these z's are going to cancel out, leaving us with negative 1 in the numerator. You got to be careful, don't lose track of that. And then we're going to have 7 minus z plus root 7. So if we take the limit of that as z approaches 0, we get root 7 plus root 7. So root 7 plus root 7 is 2 root 7. All right. Now, those are our main 3 techniques for today, but we also have some special trig limits. And